Let's look at OpenStax College Physics, Chapter 14, Problem 55. At what net rate does heat radiate from a 275 square meter black roof on a night when the roof's temperature is 30 degrees Celsius and the surrounding temperature is 15 degrees Celsius? The emissivity of the roof is 0.9. All right, so let's write down the things that we know. So we know that the area of the roof is 275 square meters. So that's the area of the roof over here. And we know that the temperature of the roof, T sub R, is 30 degrees Celsius. And the temperature of the air is 15 degrees Celsius. So we have T air and T roof. We also know that the emissivity of the roof is 0.900. And we're looking for the net rate at which heat radiates. So we want Q over T net. All right. So any object will both absorb radiation and emit the radiation. So the amount of heat radiated by the roof, so this is heat radiated, will be negative because it gives off heat. It doesn't absorb heat. It's negative E sigma A T roof to the fourth power. Then the heat that's absorbed by the roof is positive because it is absorbed. So that's E sigma A T that the air gives off to the fourth power. So that means that Q over T net, which is what we're looking for, is the sum of these two. So it's Q over T radiated plus Q over T absorbed. And that will be E sigma A, temperature of the air to the fourth power minus temperature of the roof to the fourth power. So Q over T net will be 0.900 times the Stefan Boltzmann constant, which is 5.67 times 10 to the negative eighth. Area is 275 square meters. And then the temperature, remember that it has to be in Kelvin. And I am given temperatures in Celsius, so I have to add 273 degrees to 15 for the temperature of the air and raise that to the fourth power minus 273 plus 30 and raise that to the fourth power. And when we multiply the numbers together, we end up with negative 2.17 times 10 to the fourth watts. So that means that the roof is losing energy at a rate of 21.7 kilowatts.